Hey, what's up people? Welcome back to Leo Native. Today we are going to learn how to integrate augmented reality, how to detect planes, and how to control 3D objects in real time. For this video, I have a blank project already configured with Expo because we are going to focus directly on the augmented reality implementation. If you don't know how to create and configure a project from scratch with Expo, don't worry, I leave a link in the description where it's explain step by step how to do it. First, inside our project, open a new terminal and run the following command to install the required dependencies. Okay, perfect. We delete this code because we will not need it. I will leave a link in the description so you can download the assets that we will need for this project. Bumblebee and materials. Texture image is used to give color and appearance to the car model. Car body and car wheels. 3D models of the car in .vrx format. This contains the geometry of the object that will appear in the scene. Pedal axle and pedal reverse. Image used as a control buttons to move the car forward or backward. Tracking diffuse image is used to visualize the plane detected by AR. Wheels base color and materials. Texture image for the wheels and that define their color and visual details. Now move this whole folder with the files into the assets folder of the project. We will create our first functions for the AR eScene and the project logic. We receive a product called eScene Navigator, and this product comes from the ViroReact eScene Navigator, which we will see later, don't worry. First, let's start with the surface detection using the camera. Okay, cons on camera AR heat test is a property of ViroReact eScene. We will look through the result to detect when a plane exists. When we find it, we update the position and the other states. Okay, we need the orientation and the position of the camera to calculate a new position in 3D space. In this case, we calculate a distance of 1.5 meters. At this point, phone place is false until a surface is detected. Now we will render the reticle. This is a visual indicator that shows the position where a 3D object will appear. Make sure that the components are imported from React-viro, and we will start adding the necessary properties. I already tested these values, but you can modify them if you want, don't worry. One Viro image is used while the surface is being detected. And another one is used when the surface is already detected. Make sure the asset path and the file name are correct. Now, we render the card, the body plus the 4 wheels. We will need the position and the behaviors. We will also declare the ref variables that we will need. Globally, we will use some contents, in this case, car scale. We also add a bit of ambient light for the lighting. First, the 3D object of the car body. Make sure the asset is correct, the type is ViroReact, and the resources are copied from the assets folders. Second, and the wheels. We start with the front left wheel. We declare a Viro node with the correct position and reference, and inside we place the 3D wheel object with type ViroReact. Rotation and resource. Copy and paste for the front right wheel. Change the X positions, the reference, and remove the rotation. Copy and paste for the rear left wheel. Change the C position and the reference. And finally, copy and paste for the rear right wheel, change the X and C positions, the reference, and remove the rotation. And now we get the initial orientation of the car and calculate the initial direction in the 3D eScent. In the use effect, we call the function initCarDirection inside a timeout to start an update loop. Now it's time to return driving is sent. We import ViroAR is sent, and it is property we add function that we create before. We will create a function to control acceleration and reverse. For this, we will need some global constants. We also need a ref that stores the direction and a mutable state that stores acceleration, speed, and other values. We create functions that update the physics of movement of the car on every frame. After implementing the position logic, we add the rotation logic so the wheels rotate exactly as needed depending on how far the car moves. Then we update init car direction to start an update loop with that tick function. We also clean the interval when the component is unmounted. Now, we create the main component, which contains the UI and the driving controls. We need a state to know if the scene is ready and another one to detect if the object is on a surface. We render the surface placement button and use style sheets for the styles. The idea is that this component helps us place a car on a detected surface, but only when the system finds a valid surface. Then we render the driving controls for acceleration and reverse. This component will show two touch pedals, accelerate and reverse, that control the movement of the car. Make sure that pedal assets for reverse are loaded from the correct path. Finally, we return a ViroReact navigator sending some props such as the direction, if the isCen is ready, and if the surface has been detected. We pass our driving isCen as the isCen and load our functions. Before running, we need to configure our metro-config file so it supports a new asset, in this case VRX. In the add.config file, we also add the permission required for Augmented Reality. The code I am copying will be available in the description. And inside plugins, we add the configuration for the react-viro library. Perfect, and now let's build a project by running the following commands. It is important to run the project on a physical device, not an emulator. As you can see, everything compiled correctly, and now we will see the final result directly on the phone.